So in this problem, we are given the value of sine of angle A, that's 4 over 5. Cosine of angle B is 5 over 13. The condition given here is that both angle A and angle B lies between 0 and pi over 2. So let's understand this with the help of our Cartesian plane. So we have our Cartesian axis. We have x, O, x prime. So this is the x-axis, and we have y, O, y prime, which represents the y-axis. Now these two axes divides our Cartesian plane into 4 quadrants. We have first, second, third, and the fourth quadrant. Now, the first quadrant, the angle value is between 0 and pi over 2. So this is where our angle A and B lies, and we know that in the first quadrant, all trig functions are positive. So we will go with this. Now, we'll have to find out the value of sine A plus B, cosine A plus B, sine A minus B, and cosine of A minus B. So let's state the values of each of them. So we know that the value of sine A plus B, so that's given by sine A times cosine B plus cosine A sine B. Now, if we have negative here, then this will become negative. Then we can also define the value of cosine of A plus B. The cosine of A plus B will be cosine of A times cosine of B. If we have a positive here, then this will become negative. So this will be negative sine A times sine B. And if we have cosine of A minus B, then we'll have a positive value. So we have the value of sine. In order to find out the value of sine A plus B, we need what? Sine A cos B cos A sine B. So here we are already provided with the value of sine A and cosine B, meaning we need to find out the value of the remaining two, which is cosine A and sine B. So let us begin. Now, to find out the value of cosine of A, we can use the fact that we know that sine squared theta plus cosine squared theta, so that's a standard identity with a value of 1. So to find out the value of cosine theta, we can rewrite this equation as plus or minus square root of 1 minus sine squared theta. And if we want to find out the value of sine theta, this can be expressed as plus or minus square root of 1 minus cosine squared theta. Now, in our case, we need to find out the value of cosine of A. Since we have sine of A, cosine of A can be also expressed as plus or minus square root of 1 minus sine squared A. We can plug in the value of sine A with 4 over 5. That means we have plus or minus square root of 1 minus, we have 4 squared, that's 16 over 5 squared, so that's 25. Solving this, we get plus or minus 3 over 5. Well, we are getting here two values, one positive 3 over 5 and the other being negative 3 over 5. But since angle A lies in the first quadrant, so we should get a positive value because cosine function is positive in the first quadrant. So now we have the value of cosine A. Now using the value of cosine B, we can find out the value of sine B. So sine B, we can use this formula. So where sine B will be plus or minus square root of 1 minus cosine squared B. So this is going to be equals to plus or minus square root of 1 minus. So cosine of B, that's 5 over 13. So that squaring it gives us 25 over 169. Solving this, we get plus or minus 12 over 13. Again, we are getting two values, one positive and the other negative. Since we are in the first quadrant, so sine of B will assume only the positive value. So that's 12 over 13. Now that we have the value of cosine of A and sine of B, we can easily find out each of the given trigonometric ratios of the compound angles. So let's begin with the first one. So we have sine of A plus B. So sine of A plus B, so we have sine A times cosine B. So sine A, that's 4 over 5 multiplied to cosine B. So cosine B is 5 over 13. Plus, then we have cosine of A. So cosine of A, we got the value as 3 over 5. So this will be multiplied to sine of B, which is 12 over 13. So when we solve this, this is going to give us the value 56 over 65. Right. Now let's move on to the next one. We will have to find out the value of cosine A plus B. So cosine of A plus B, so we need the first term cosine A multiplied to cosine B. So cosine A is 3 over 5 multiplied to cosine B. The cosine B is 5 over 13. Minus sine A times sine B, that's the second term. So sine A, that's already been provided to us, which is 4/5. So we have 4 over 5 multiplied to sine of b, so that's 12 over 13. Now we can compute this value. So this is going to give us negative 33 over 65. So this is the value cosine of a plus b. Coming to the third part, so third part is sine a minus b. So that's quite similar to sine a plus b, only this positive sign will be replaced with negative sign. So we have 4 over 5 times 5 over 13 minus 3 over 5 times 12 over 13. Solving this gives us the value negative 16 over 65. And finally, we can find out the value of cosine of a minus b. So it's quite similar to cosine of a plus b, except the sign negative will become positive. So 3/5 multiplied to 5/13 plus 4/5 multiplied to 12/13. So solving this, we get the final value 63 over 65. So finally, we have the value for each of the trigonometric ratios: sine a plus b, cosine of a plus b, sine of a minus b, and cosine of a minus